This is Chapter 8, Example 2, and what we're going to do is design a circuit. So the circuit has 4 8-bit values that it adds, and it's going to return the proper summation on the circuit's output. And it specifies directly that there's no carry out on this circuit. That defines it pretty good, and the first step is going to be our black box diagram, and it adds 4 8-bit signals. The output is, here's the issue. The output must be valid. We want to make sure this output is always valid. And so we have to specify the bit width of this such that it's always valid. Now the issue here is I'm adding 4 8-bit numbers. So that's essentially 4, let's do this right, 4 equals 2 squared. 4 8-bit numbers is what we are going to add, so essentially that's 4 times the maximum value here to the 8th. So if you do the math on this thing, this is going to be 2 to the 10th. 2 to the 10th is going to be, roughly speaking, it's not exactly right, it's going to be the maximum possible value of this problem. So this is what we're interested in. We need a bit width of 10 to represent this problem. That's our top level black box diagram, and from there we can actually start designing this thing. The issue here is I have to, because there's a bunch of different ways to do this, but the only way I know how to do this is using a ripple carry adder. Ripple carry adder adds 2 values, 2 operands at a time, and so we can start by plopping down some ripple carry adders. I know I'm going to have to do at least 2 of these. C and D, and these are 8-bit. We can put the A and the B carry out. Okay, so we're going to actually use these. So when I add 2 8-bit numbers, it could potentially, if it overflows, give me a 9-bit result. The carryout represents the 9th bit, and so what I'm going to do is take advantage of that, and what I'm going to do, here's my little append notation. This carryout becomes the 9th bit. I'm appending it to this thing, and I'll put a note there, CO. So that looks good there. So I'm going to do the same thing with this circuit. Here's my little append notation. And this becomes 9 bits. Okay, looking good. This means I've added 2 of these things. Now I need to sum these 2 values, so only way I know how to sum 2 values is once again with a ripple carry adder. So these are 2 9-bit values here. Label this correctly because we're going to need those. And so the sum is also going to be 9 bits, but we need that carry out. We need to append that to make that the 10th bit, and this is the final sum. And we'll put a note there saying CO, and that's all I got here. Remember, this, what I've done is this sum here, is this sum here. I know we got some internal sums kicking around in there. This A, B, C, D here is this A, B, C, D here. So this is, again, a circuit using ripple carry adders. Ripple carry adders have no control input, so this circuit has officially no control, meaning the circuit just reacts to the inputs.